Geology students, today we're going to talk about the rock cycle real briefly and then get into magma and igneous rocks, which is the first rock type that we're going to be talking about. So just as a review, remember minerals, which we've already talked about, are what make up, they're the components that make up rocks. Okay, so you can see here in this piece of granite we've got these different minerals down here at the bottom: quartz, hornblende, and feldspar, that are going to be making up the granite. Okay, so that's true of all rocks. They're just made up of different minerals. So igneous rocks, which we're going to be talking about today, literally means fire rock. So it's born from cooled magma or lava. Okay, so we're taking that magma lava, cooling it off, and that's going to form our igneous rock. Sedimentary rock, which is the next type of rock that we'll talk on later this semester, is kind of based on its name, right? It's going to be formed from sediments. Okay, so you take a little piece of sediment, get them to lithify together to form a sedimentary rock, and then the last type of rock is a metamorphic rock, which will be towards the end of the semester we'll talk about. And these are existing rocks that get modified or changed by heat and pressure. Okay, so those are the three types of rocks. And rocks, we say, have a cycle because they change from one form to another over time. So this diagram you see in the notes here, with all the arrows pointing in all kinds of different directions, we're going to be filling this in throughout the semester, so talking about the process of how these rocks can change from one thing to another type. Again, what we're going to focus on today is this process down here that I have circled, and that is the igneous process. So we're talking about magma, lava, and then cooling to form igneous rocks. Okay. First thing we need to make the distinction of is what's the difference between magma and lava. It's a very common mistake or misconception. A lot of people think they're the same thing, but they are not. Okay. So magma is molten rock that's below the surface of the earth. Okay. So it has not come to the surface, and that can be solids, liquids, or gases, and a mix of all of those things. Whereas lava is when magma has come to the surface. So really, it's just semantics as far as location where we find this stuff. Okay, but once it gets up onto the surface, like we would see in a volcano, we then refer to it as lava. So that's an important distinction. Now, how does magma inside of the earth form? So, rock, if you get it hot enough and you get a high enough temperature, it's going to melt, right, and turn into what we then call magma. But can you guys think of any other reason that would cause magma to form? Is there another way to get a solid thing to melt? Okay, and these are a little bit not quite as easy to figure out, but they should make sense once we talk about them. The first one is a decrease in pressure, which we'll talk a little bit about in more depth here in a second. And the second one is the addition of volatiles. Now what that's talking about is adding water, carbon dioxide, etc. to those. Now for pressure, now think about this. If you guys have been around a gas grill at all, maybe you haven't been, but that big tank that's attached to a gas grill, you shake it around and it's a liquid. And when you open up the valve and release the pressure, it turns into a gas. The same thing is happening here with magma, whereas deep inside the earth, okay, the mantle is kind of in a semi-solid state. It's not, a lot of people think the inside of the earth is just filled with all this liquid magma flowing around. It's not. A lot of it's a solid state material. So as it gets pushed up to the surface, it's under less pressure, and when it's under less pressure, it then begins to melt or turn into a liquid. So that's how one way that magma is formed. Another way is the addition of volatiles. Now with volatiles, what we're talking about again are water, carbon dioxide. So we'll learn more about this process here called subduction later in the semester, but sometimes plates of Earth's plates get pushed down deep underneath other plates, and as they go down they heat up, right? But then when this plate comes down, it's going to be pulling water with it, it's going to be pulling organic material with it, carbon, and then what that's going to do, it's going to lower that melting temperature of that magma. So it's going to allow this rock, if you will, to melt more quickly and turn into magma. Okay, so those are two, in addition to just heating up, those are a couple different ways that magma can form. Okay, now when we get into rock, so that's the formation of the magma, but when the magma cools off, it starts to crystallize. So through a process of crystallization, you've got your magma, and then eventually, as it cools off, crystals start to form. And eventually you get to the point where it has totally crystallized, and then it is turned into a rock, or an igneous rock. Okay, so that's the definition of crystallization. It's the formation of mineral grains. Okay. Now, how do we identify igneous rocks? Now, there's two key questions. Okay, is it light or is it dark? Does it have big crystals or small crystals? Those are the ones you really need to focus on and understand what they mean. Okay, so let's flesh those out. So what we use to figure out the composition, okay, or what they're made of, is we use the Mafic color index, the MCI, to look at, well, what's in this igneous rock. Some rocks we'll call mafic. Now, mafic rocks are dark. Okay, so just think when you see a dark rock, think it has a mafic composition. So heavy, dark minerals like iron and magnesium. Okay, and they tend to have a lower percent of silica, and we'll talk more about this in our next notes as well. But 45-52%. Again, you don't need to know the exacts. Just understand in general they have less silica than felsic. Okay, so felsic is the opposite. Felsic are going to be lighter in color, okay, and density, with elements like potassium, aluminum, and sodium. They have more silica in them. I put the Godfather up here just as a way I remember, when I learned this, was I thought Mafic, Mafia, you know, guys wearing dark suits. So that's just a way that could maybe help you. All right, so here's the MCI, and you can see it's just a range. If your rock looks lighter in color and kind of has this kind of shading, it's probably felsic. If it's more dark, it's mafic. Really, we don't deal with ultramafic very often. And then intermediate, it's just going to be kind of a gray color rock, somewhere in the middle. Okay. So we have this chart like this, and then we can use that general MCI up here. So if we have a rock that looks like this, right, from Minecraft, we can take that and say, well, that's intermediate. We can then figure out, well, what is its mineral composition? So I just have to go straight down, and then on a chart like this, we'll see something like this in a lab that we'll do. As you can see that, well, that's about 10% quartz, about 5% potassium feldspar, et cetera, as you go down. And you're able to then determine the approximate mineral composition of that rock, okay? But again, just remember, you know, that medium, it's going to be intermediate, light, felsic. If it's dark, it's mafic, okay? All right, that brings us then to when did they form, or when did this rock form? So we had this guy Bowen, and what he did is he was able to figure out how magma crystallizes and that there is an order to which it does. So basically what he did was that he had a hot furnace, and he was able to create his own lava or magma, and then he let it cool off, and he made observations. And what he figured out or saw that the most important factor is silica. And I'll go through this a little bit more in more detail, but by letting them cool off, he was able to see a general pattern with what happened. And this was the pattern that he saw. And again, all I really want you guys to be aware of is that when he let them cool off, the first crystals he saw were dark crystals. Okay, so those are when magma starts to cool off, the very first things that start to form are the mafic, or the darker crystals. And then eventually over time, then finally the last thing to crystallize is your quartz, okay, which is silica. Okay, so as magma cools off, because the dark crystals start to crystallize first, the magma over time generally becomes more silica, or more quartz-like, more felsic. Okay, so if you have a body of magma and it has a lot of silica in it, okay, or a high percentage of silica, it means it's been there for a long time. It's taken a long time to cool because those other minerals have cooled off, or those other darker minerals have formed, excuse me. Okay, so then when or where did they form? Okay, so we've got a couple terms for you here. Extrusive rocks are going to be rocks that form extrusively, exit outside on the surface. Okay, so they're formed above the surface. And because they cool off on the surface, they cool off quick. And because they cool off quick, they're going to have small crystals. Okay, so the crystals don't have a chance to form. Okay, so when that comes up to the surface, it's going to cool off real quick. Now, intrusive rocks are going to be when magma cools inside of the earth very slowly over time. And because they form very slowly over time, that gives crystals a long time to form. Okay, so you're going to have large crystals when you have intrusive rocks. Okay, so this is giving you an idea of that process. So if you have magma that cools off very quickly, it's going to lead to small crystals. So you can notice on this piece of basalt here, you can't really see any crystals. If you have a piece of magma or segment of magma that cools off very slowly, the crystals have a time to grow and be larger, and that's going to large to a more large crystal rock. That's telling you that it's cooling off very slowly. Okay? Now that then leads to, well, what's stuff made up on Earth? If we look at our continents, it's mostly granite. Okay, so if we look at this granite, right, think, is it felsic or is it mafic? Okay, well, that's felsic, right? It's very light in color, meaning it has a lot of silica. Okay, and the second thing we could look at is like, well, did this cool intrusively or extrusively? Well, it's got large crystals, right? You can definitely see the different crystals in here. That means it cooled off intrusively. So we know from granite, this got stuck inside of the earth, right? And it cooled off very slowly over time, so it has these large crystals. And this, as far as mineral composition, had a lot of silica in it, okay? Not very much of those mafic minerals. Now, on the other end of the spectrum is the ocean crust. Now, the ocean crust we find is mostly basalt. Now, basalt, again, look at this. Okay, is this guy mafic or is he felsic? Yes, he's mafic, right? Lots of dark minerals in there. And then intrusive or extrusive? Yeah, that guy is extrusive. Notice the small crystals. You can barely see anything, right? Really fine grained, really small. So that means this guy cooled off quickly. Okay, and we expect that because of that mafic magma comes up to the surface really easily and is able to cool very quickly. Therefore forms these small crystals. Okay, so as far as trying to figure out, when we look at a rock, we'll do a lab where we're trying to identify these different rocks. There's a bunch of different classifications for them that you'll see. Again, you won't be necessarily required to memorize these, but we'll use them in labs. Okay, so there's a glassy texture. It cools off so fast crystals can't form. Vesicular means it's very bubbly, means that the magma had a lot of gas in it. Aphanitic means not visible crystals. So the crystals are so small, you need a microscope to see the crystals. Okay, versus phaneritic. Phaneritic means it has visible crystals. So this would be like granite, where you can see the crystals. Porphyritic just means that you've got medium or mixed coarse grained crystals inside or forming inside of the mix. Here's a picture of that, so you can see these crystals that formed inside of this other mix. So a lot going on there. Identifications can be confusing, but we'll do this in lab, and it's really not too bad. The key thing is, again, first identify if it's felsic, mafic, or intermediate. Second thing is try to figure out the mineral composition. And lastly, look at the texture. So you can go straight down from here, and if you have a felsic rock, and that's phaneritic, it's granite, okay, et cetera, as we go across. Okay? If you have any questions, just rewatch this video again or shoot me an email in class.